Hey everybody, it's Matt with Downrange Warbirds. We are back with an update on the P40 Warhawk build project. A lot of cool stuff going on. You're going to see me dig into some of the back-end stuff that's not direct construction. So this is SolidWorks. It's very, very cheap for builders, and in my case I qualify because I'm not using it for commercial purposes. So as you can see here, I'm actually building the control mount assembly for the flight stick, for the actual control stick. This is kind of an important one for me right now because while the skins are off, it's a little easier to access where this is going to mount to the spar section of the aircraft. And part of that's going to be through actual part of the frame that's on the fuselage. So in order to simplify my life a little bit, I wanted to get this done first. You would see videos of this from before, except I've been learning how to use SolidWorks for the last 2 or 3 months. I've done a bunch of various brackets of varying sizes and whatnot. You can see some pictures throughout, and you'll see bits and pieces of them throughout this video, but this is the big one that we're doing. Basically, it's just starting with a flat image, sketched image, and then building the elements that matter. You can see that square right smack dab in the middle. The circle is going to be out, and I've got blown up on the top right of the screen there is the drawing that came with the blueprints that I'm basing everything off of. So from there, you're seeing me do all the drawing and the modifications and all the good jazz that goes with that. So that device that I'm using right there is basically a measurement tool for dimensioning. Lets me put very, very accurate dimensions on parts to make sure everything's going where it's supposed to be, angled where it's supposed to be, mounted where it's supposed to be. It helps with defining the drawing very, very specifically so that when I put it into 3 dimensions, it's going to make it very, very accurate and there's not going to be any errors, especially because once this diagram is done, I'm sending it off to Send to Cut Send to have them cut the brackets for me. I'm not going to mess with it. I've technically already made some of these brackets, but I'm redoing everything in SolidWorks and then sending it off to Send Cut Send because the quality is going to be infinitely better. They have a precision brake built for what needs to be done in this situation. As that's the case, it just makes more sense to have them do that work versus me trying to do it on a 10-ton piston ram and trying to jury rig a brake out of it and hoping that it's all going to be accurate and precise and I'm not going to end up destroying my parts once I put them in there. I don't have the ability to easily heat up joints to make sure that they're soft enough to be able to make the curves, especially with the 4130 chromoly steel plate that I'm using. I don't want to mess with that when I don't have to. These surfaces exist so I don't have to sit there with a grinder and a cutoff wheel trying to be an artist with a material that I'm not very comfortable familiar with. I'm already trying to learn how to weld on this thing. Let's not reinvent the wheel if we don't absolutely have to. So this other piece right here is something that I figured out after I've already drawn this part once and I try to submit it. This is a tab, so when you're actually bending on it, they need more material to bend on. They said something that was at least 1 inch long and parallel to the direction of the bend. That dotted line that you see there going up at a about 30 degrees from north there, that is our bend point, or pretty close to where it's going to be. So I needed to extend that tab 1 inch wide and far enough out. And then what you'll see me draw in here is a little connection points. They're break-offs for the tab. So once this is done, I will just cut off those tabs, remove the entire piece, grind that down so they're smooth and flush, make sure they're nice, purdy, and not going to cause any issues. And then I just remove the tab after the fact once it's actually delivered. Super easy process to do. That came from Send Cut Send that I had to do it that way. I wish I didn't have to, but so there's going to be a couple areas that are going to need a little attention when this is done, but not the end of the world by any means whatsoever. So that's that segment right there. From there, just got to add the extra dimensions for the bends just to make sure that this thing's going to be accurate. So once this thing becomes a 3D model, we need to be able to bend it to the proper shapes too, because all that's going to get done in SolidWorks. So by the end of this part, you're going to see that all happening. So that's kind of how this whole process works. So this whole thing has been dimensioned basically to this point. Now I just need to duplicate it on the left side because you can see from the drawing this is it's supposed to be identical and symmetrical on the other side. So I need to draw this center line point, that dotted dashed line that's going top to bottom that I just added in there. That's kind of our mirror point. Dead center on the bracket, we hit mirror on that. And once all the right components are selected, and I'm working on that right now, there's a ton of objects in here which can kind of cause some issues. and that's where I'm messing with that too right now, and it mirrors it over just like that. In order to make this one solid flat drawing, I've got to do exactly what I did there and remove all that, and then I need to remove the tab components as well here. You're going to see me zoom in here in a moment, because unfortunately right now it is not a single solid entity. I need to go in and actually get close to those tabs and remove those. Right there, you see me doing it. Or trying to. I need to get a little closer because they're small tabs. But once those are all out, boom, you now see the solid geometry, and then from here, I can actually go to the sheet metal tool. Oh, before I get to the sheet metal tool, that's right, I drew the circles out here. So, pardon me. So those are going to be the actual screw holes for everything else for the mounting. So that's going to be what actually mounts the control arms is going to be to those two little brackets. So there's going to be control lines that are attached to that stuff. The holes that I'm drilling right there are going to be for the physical mount to the spar. So once those are dimensioned and taken out, that'll get mounted directly to the spar. I'm drawing them now because when I make this thing in 3D and turn it into sheet metal, it'll actually remove those segments. So it simplifies that. So each of those is 0.187. I think it's 3/8 of an inch. They're all 3/8 inch holes. You see me having to dimension decimally. I wish there was a way to do it with fractions, but if there is, I don't know what it is, so I have to learn the numbers. I've memorized some of them, but usually I have to break out the old calculator to make sure that they're all square and proper. And then once all three of those are drawn out, we'll do the same thing that we did when we copy the geometry from the right to the left. We'll copy the locations and the holes from the left to the right using that exact same mirror function on SolidWorks. As you can see, this is kind of very precise, but the nice thing about the all those tools, that dimensioning tool, is you can get this stuff very, 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 very accurate, so you don't have to worry about any guessing games. When these get cut, because Suncut Sun is a laser cutting service, beats the heck out of me with a hand grinder. They're going to be very, very accurate. So there you can see that with that mirror function, it duplicated those circles exactly where we needed them to go. So part of this is just checking to figure out, make sure everything looks good. The whole solid is selected the way it needs to. And then from there, I use the sheet metal tool and make it the thickness that I want to make it. So in this case, I think it was supposed to be like 0.12 something. The next closest size was 0.125 thick chromoly steel. So that's it right there, getting the dimension set. And there is the flattened laser cut part. That's what it's going to look like initially before the bends get put into place. Before I can put the actual bends in, I need to do a couple more features on this. So as you can see in the drawing, there's curved corners as opposed to having sharp angled points on this. We're going to make sure that we address that here in that drawing. So you can see me selecting each of those corners, and then I'll actually put a chamfer cut, or a fillet, I should say, not a chamfer, but a fillet, and I can put those arcs in there. So those are a little small for that drawing, so you're going to see me go in and actually change the radius on these here momentarily. And that should be happening right there. Just extend those radiuses just a little bit, smooths them out, cleans them up, and then the interior radiuses. This is also going to make life on the bend itself a little easier because it's actually going to extend the bend a little bit into those tabbed wings as opposed to putting it right against the corner. If I did it right against the corner, there were going to be some issues with deflection from the rest of the part because it was going to be in the way and there would be no good way to make that bend right into that corner. So once I get these fillets done to the right sides, because these are supposed to be, I believe, 1/8 fillets, that'll shrink that up, and then you're going to be able to see where I put my perpendicular lines when I move back onto the flat face. So far, this is the gist of what you're looking at. You're seeing the bend portions. Now we're just switching back to that top view so we can draw back on that face. So we'll go back to the sketch mode, click on that face, and then we're going to start grabbing some corners to draw the bend lines. So we're not going to use the very corner. we're going to use that slight offset right at the edge of the curve there. That's going to be our best bet for getting that. So we just push it, and then those yellow lines that kind of light up when I brought it up to the perpendicular there, that shows exactly where that perpendicular is. So I stick that point right there, and that's where those lines are now drawn on this topmost face. From there, I go back to the sheet metal tools, and here I can actually select those bend marks, which is exactly what those are there, and then just to put the appropriate bend location on it, and there is a holographic see-through image of what that bend's going to look like once it's done. At this point, that's pretty much exactly where I want it to go. Now all I have to do is select it and make it a permanent step by hitting that little green check at the top left, and boom, I have a 3D model done with bends, and that's what she looks like. So I'm going to do another one of the brackets here just because why not? We're here. I recorded it. Might as well use the material so you can kind of see what I did. It's one of the brackets that's actually going to weld to that control mount. It's another rectangle shape. You can see it at the top there. That's actually two separate brackets. There's a 3D image that I didn't include in this one. I'll show it to you here sooner than later. Plus, it's going to get welded up in the next couple of weeks, so you're going to see it firsthand. It's actually going to be the larger of that rectangle. So you can see it's the tall, lengthy component of it. The dotted lines are the optionals. So in this case, it's going to be one solid bracket, top to bottom. Start out with that rectangle. Make sure I define all of that good jazz. Get those circles put into place. They're going to be on the left side, and then again, like before on the previous tool, we'll mirror those over. Cut those the appropriate side. Each of those, I believe, is a 3/16 diameter hole. So those will each get cut and then spaced appropriately. You can see that on the drawing as well. 5/16 from the top edge, and then 3/8 and 3/8 between each of them. Right now, the diameters are on point. Now I just got to get the spacing down. So that's what we're doing right there, is getting it even off the edge, and then breaking those down 3/8 apart from each other. At this point, I think I actually have the wrong number in, so I'll actually make that correction here momentarily. Because it's 5/16 from the top one, and then here you see where I make the correction and realize, oh, that's not right. 3/8, 3/8 instead of 5/16 off the top. So those are each getting corrected right here. And that fixes that particular problem. From there, that's just the center line, because I need that to cut the mirror. Or reflect, I should say. Not cut the mirror, but reflect those 3 holes onto the other side here. This piece is a lot easier to put together than the first bracket. I think this one only took about 7 or 8 minutes to actually do the whole thing top to bottom. This is making it a sheet metal, and it already pre-drills all the holes. That was the perk to doing the holes up front and getting those circles put onto the flat sketch. From here, it's just adding those fillets on each of the corners to make sure we have the right angles and diameters. In order to cut that arch on the very bottom, I actually need these fillets in, since, as you can see from the drawing, they match with the edge of the fillet perfectly. So once I get those drawn with a 5/16 inch radius on all 4 corners, what would they go from there? There is a way to auto-select all 4 corners. I couldn't remember for the life of me what it was. I'm sure I'll figure it out here over the next couple of days and weeks. But right there, it's drawn in. Of course, I think I only did 1/8, so I had to remove that and do it over one more time. So my apologies on that. But you're getting a very minimally edited variation of this video. But we do that fillet again, and then we actually put the right radius in it now. There we go. That actually looks like it was done properly. Let that actually cut. Hit the check mark to ensure that and save it. Perfect. And then change from that orthographic view to a top view by going back to sketch mode. And now here's where we have to draw that circle section, that segment. So basically we're just going to use it to draw a perfect circle with that 9/16 radius that's listed. So we can do a 3-point circle like that. So we basically put the endpoints that need to be fixed and then have that floating one, and then just use the smart dimensioning tool to set the radius where you want it to go. So it does diameter, so obviously it turns into, instead of 9/16, it's 9/8. No big deal. Just got to do the conversion. I just got to figure out where I wanted to put the angle on that. I get a little twitchy that way. Once that's defined, then now it's just a matter of doing an extrusion cut. That's in the features menu. Once there, I skip from doing blind through all. So it just does a completely perfect cut right through the entire thickness of the bracket. Once that's done, you're looking at the completed bracket at that point. So now we can just take a look at it, spin around in circles a little bit, and there you go. Final completed bracket. Thanks everybody for tuning in, and there will be another video next week, hopefully.